Okay, hi everyone. So in this video, we are going to talk about the reciprocal trigonometric ratios. Okay, and this exit pass, we're going to look at cosecant, secant, and cotangent. Right. So cosecant is 1 over sine, secant is 1 over cos, cotangent is 1 over tangent by the third letter in that one. Okay. So this is a neat way to remember. Okay, let's try exit pass question 1 without using a calculator, evaluate all these things. So we're going to need the help of what do you call this? Special angles. Okay, so 45 degrees. So what is cosecant of 45 degrees? Okay, so with this, I'm going to draw out the 45 degree triangle, right? So the 45 degree triangle is 1, 1, root 2. Okay, and I'll be using this triangle to help me with this question. So 45, so cosecant. Okay, so cosecant 45 degrees is equals to 1 over sine 45 degrees, right? So what is 1 over sine 45 degrees? This is 1 over sine 45, so it will be 1 over root 2. Okay, if I may, I will write it like this. Okay, so keep, change, flip, so this would be equals to root 2. Okay, next, secant. Okay, so secant of 45. Right, so secant 45 is 1 over cos 45. Okay, so in the same way, this is also 1 over root 2. So keep, change, flip, I will get root 2 again. Then last but not least, cotangent. So cotangent of 45. Okay. Right, so cotangent of 45 degrees. So this is 1 over tangent 45. So tangent 45, right, over here is 1. So 1 over 1 would be 1, just like that. Okay? So this is for 45 degrees. Now, second, 4 pi over 3. So where on earth is 4 pi over 3? So 4 pi over 3 is going to be in the third quadrant. Okay, it's how many degrees? 240 degrees, I think. Yeah. So this would be 4 pi over 3. This is pi, 180 degrees is pi. So the basic angle that I'm looking at, this basic angle, right, would be 4 over 3 minus 3 over 3, so it's just 1 over 3 pi. So this is pi over 3, right? And then I can think of it in terms of the pi over 3 is 60 degrees, right? So let me draw out the 60 degrees triangle so that I can, yeah. So the 60 degrees, right, this is 1, hypo is 2, and the opposite would be root 3, okay? So let me remove this. Okay, so I have this triangle over here, and then let's try to go with 4 pi over 3. So cosecant of 4 pi over 3 is equals to 1 over sine of 4 pi over 3. Now, for sine 4 pi over 3, right, this is actually equals to sine of pi over 3. Right, pi over 3. When I relate it to the basic angle. Okay, so sine 4 pi over 3 is equal to sine basic angle pi over 3. But in quadrant 3, or ASTC, so sine would be negative. So let me put in this 1 over negative, opposite over hypo, so 1 over negative, root 3 over 2. So this would be negative 2 over root 3. Okay, so like that. Okay, next one. Or maybe let me move this away. Yeah, let me move this here. Yeah, and let me move this one over here. Okay, easier to see. Okay, next one. Wait, one more. Let me move the whole thing here. Okay, next one. So let's take a look at secant 4 pi over 3. So secant 4 pi over 3 is 1 over cosine of 4 pi over 3. So then it will be 1 over cosine of basic angle pi over 3. In quadrant 3, ASTC cosine is negative. So then it will be 1 over negative of adjacent, which is 1, and then hypo is 2. So keep, change, flip, so this will be negative 2. Okay, last but not least, let's take a look at cotangent 4 pi over 3. So cotangent 4 pi over 3 is equals to relate to the tangent. So 1 over tangent 4 pi over 3. So then it will be equals to 1 over, now tangent 4 pi over 3 is equals to tangent basic angle pi over 3. ASTC, third quadrant, tangent positive. So I'll just leave it alone. So this will be 1 over, okay, opposite over adjacent, right? So keep change flip, so this would be 1 over root 3. Okay, so that is all with so these two angles. Okay, let's take a look at the next question. Okay, next question. Given that A is in quadrant 1 and 2, right? So let's quadrant 1 and 2, and tangent A is negative. So means this is quadrant 2 and 4. So which is the common quadrant? Quadrant 2, quadrant 2. So the angle is in quadrant 2. Okay, so let's draw out the angle in quadrant 2, angle A in quadrant 2. Okay, so angle A is over here. So this angle is A, and I'm gonna get this basic angle alpha out, and let me draw this right angle triangle. Now, tangent of this angle is negative 3 over 5, so the opposite is 3, adjacent is 5. So then the hypo would be 3 square plus 5 square, square root, so this would be root 34 over here. Okay, so this one over here, right? So this length would be, so 3 square plus 5 square, whole thing square root, so this would be square root of 34. This will be my hypo. Okay, so once again, even though tangent A is negative 3 over 5, and you may want to like say, hey, why Mr. Khoo never put like negative 5 over there? Because for me, the negative I will get from the quadrant already. Okay, so sorry for misleading you earlier. We'll just for me now, I will just focus on the length alone. Then ASTC will give me the sign. Okay, otherwise I'll do a double negative and it won't make sense anyway. Okay, so evaluate cosecant A, secant A, and cotangent A. So okay, so what is cosecant A? Cosecant A would be 1 over sine A. Okay, so we always relate back to sine, cos, and tangent, which makes it easier. Okay, so 1 over sine A, and this is actually 1 over sine alpha, basic angle alpha. In quadrant 2, sine is positive, so I will just leave it alone. Then 1 over sine alpha would be 1 over opposite over hypo. So you keep change flip, so this would be root 34 over 3. Okay, so next, let's look at secant A. Okay, secant A is 1 over cosine of A. So cosine of A, right, is equals to cosine of alpha, basic angle alpha. But in quadrant 2 ASTC, cosine is negative, right? So here will be 1 over negative adjacent over hypo. So adjacent over hypo. So you keep change flip, so this would be negative root 34 over 5. Okay, last but not least, cotangent A. Cotangent A is equals to 1 over tangent A. Right, no big deal. So 1 over tangent A is equals to 1 over tangent basic angle alpha. So then in quadrant 2 ASTC, tangent is negative. So this would be 1 over, right, negative of opposite over, okay, opposite over adjacent. So keep change flip, so this will be negative 5 over 3. Okay, so this is question 2. Alright, question 3, given that theta is an acute angle, secant theta is k is a constant, express cosecant theta and cotangent theta in terms of k. So theta is an acute angle, very nice. So it will be in quadrant 1. Okay, quadrant 1. So let me draw out this angle in quadrant 1 over here. Okay, so this angle is theta, right? Okay, so secant theta is k, which means cosine theta is 1 over k. Agree? So means that the opposite, the adjacent and hypotenuse, so adjacent is 1, hypo is k, right? And the remaining length will be k square minus 1, like this. Okay? So you see this? Okay, so sure, let's find cosecant theta and cotangent theta. So cosecant theta will be equals to 1 over sine theta. So in quadrant 1 we don't need to do anything. So this would be opposite over hypo. Okay, sure. Okay, opposite over hypo. Next one for cotangent theta would be 1 over tangent theta. So this would be opposite over adjacent. So it's just k squared minus 1 whole thing divided by 1. So it's just like that. Okay, so this is question 3. Oh, sorry. Okay, it's the other way around. Okay, 1 over sine theta, right? So 1 over, right? So sine theta is opposite over, okay, so it's like this. Okay, now I see the problem. Okay, so k squared minus 1 over k, right? So then I need to keep change flip. Okay, keep change flip, right? So this would be equals to k over k squared minus 1. Right? I'm keen to keep the answer like this, but I don't know, some people say they need to rationalize, so I'm just playing safe just by rationalizing. So I have this one, right, over this k squared minus 1. Okay, so I'm just going to do this. Right, cotangent, so this one would be 1 over, okay, this is the, okay, opposite over adjacent. So let's keep change flip. So keep change flip. So I will have 1 over this. So same thing. I'm actually, to be honest, I'm keen of doing this, but it's Cambridge, so we have to like do things in their way. Right, like this. Come on. Okay, like this. Okay, so over k squared minus 1. Okay, so once we rationalize, and then this should be fine. Okay, so question 3. Okay, last question 4. Okay, oh no, 2 more. Okay, question 4. Given that sine A and tangent B and the A and B lie in the same quadrant, find the value of each of the following without using a calculator. Okay, so sine positive means I'm referring to quadrants 1 and 2. Okay, tangent negative means I'm referring to quadrants 2 and 4. So which is the common quadrant? Because both these angles are the same, in the same quadrant, so it means it will have to be in quadrant 2. Okay, so let's draw out these angles in quadrant 2. Okay, like this. Okay, so let's say if this is A, so I have a right angle triangle like this. My basic angle, I will call it alpha. So sine A is 3 over 5, so opposite of the alpha and the hypo will be 5. So this is a 3, 4, 5 triangle. Okay, next for angle B, so let me draw angle B like this. Okay, like that. Okay, 90 degree. So this is angle B, and the basic angle, I'll call it beta. Okay, so tangent is opposite and adjacent, so opposite is 5. Opposite is 5, adjacent is 12, the hypo is 13. Okay, hypo is 13. It's a 5, 12, 13 triangle. Sure. Okay, so secant of B. So secant of B is 1 over cos B. Right? And just nice, 1 over cos B, right, is equals to 1 over cos beta. Borrow the basic angle. But in second quadrant, ASTC, cosine is negative. So this would be negative 1 over, okay, okay, cosine is opposite, so adjacent over hypo, so adjacent over hypo. So keep change flip, so I will have negative 13 over 12. Okay, cotangent of A, so this would be 1 over cot A, so this will be 1 over tangent A. Now, then because of this, I can borrow the basic angle alpha, but in quadrant 2 ASTC, tangent is negative. So this will be 1 over negative of tangent alpha, right? So alpha opposite over adjacent. So keep change flip, so this will be negative 4 over 3. C, cosecant of B plus sine negative 8. Wow, like that lah, can. Okay, So cosecant of B would be 1 over sine B. Okay, sure, 1 over sine B. Okay, I will just leave the sine A alone. Oh wait, so I think I'll just do one by one. Okay, let me do one by one, easier. Okay, so cosecant of B, right, cosecant of B would be 1 over sine B. And I can borrow from the basic angle sine beta. Right, in quadrant 2, sine is positive. Okay, so over here it will be 1 over opposite over hypo. So opposite is 5, hypo is 13 based on the angle for B. So keep change flip, so I will get 13 over 5. Okay, so this is cosecant B. Okay, okay, let's write like this. Now, what is sine of negative A? Now, A is an obtuse angle. So sine of negative A, right? So where is negative A? Negative A is actually over here. Okay, negative A is over here. Okay, so the thing with this, right, is that okay, the thing with this one is what's the basic angle then? Right, the basic angle is still alpha actually. Yeah, the basic angle is still alpha. So so technically sine negative A is equals to sine alpha. Just that now it is ASTC. Okay, ASTC. So ASTC sine is negative, so it will be like this. Okay, negative alpha. So then this will be equals to negative, okay, alpha sine is negative 3 over 5. Okay, now or the second way to do this is now sine of negative A is equals to negative sine A. If you know the negative angle formula, okay, then this will be just equals to negative 3 over 5. Okay, so with this, right, so what is cosecant of B plus sine of negative A? So this will be equals to 13 over 5 minus 3 over 5. So this is 10 over 5. So this is equals to 2. Okay, so mainly just like that. Okay, so this is part C. Now part D. Okay, let me bring this down so that I can show you what's going on. Okay, let me shrink this and put it here. Okay, now so tangent 90 minus A, right? So I'm going to make use, and cosine 90 minus B, I'm going to make use of the complementary angle formula. Okay, so let's try this and see. So tangent 90 minus A, so tangent, okay, do one by one also. So tangent 90 minus A is equals to 1 over tangent A. Right, so it's actually cotangent A. So over here, this one would be from based on this one, A. So 1 over tangent alpha. Okay, but in quadrant 2, this would be negative. So this one means it will be 1 over negative of opposite over adjacent. So keep change flip, so negative 4 over 3. Okay, next one, cosine of 90 minus A is equals to sine A. And what is sine A? Sine A we can relate to sine alpha. And in quadrant 2, sine beta. Because this is B. Right, sine beta. Okay, so in quadrant 2, sine is positive, so I leave it alone. So based on beta, opposite over hypo is 5 over 13. Right, so therefore my tangent 90 minus A plus cosine of 90 minus B. So this is going to be equals to negative 4 over 3 plus 5 over 13. Okay, so simplify negative 37 over 39. Okay, so like that. So I will just split this out to write, so otherwise it will be taking a lot of steps also. Okay? Okay, so last one, the bonus one. So given that cosecant of this in quadrant 2, right, this is quadrant 2. So find the values of k if this happens. Okay, sure. So cosecant of this, right, means, okay, so cosecant of theta is 1 plus k square. Right, so this means that the sine of theta is 1 over 1 plus k square, right? Because it's the reciprocal. Okay, so with this one, we will draw an angle in quadrant 2, and let us try to find out the length over here. Okay, in quadrant 2, this is theta. I'm going to call this alpha, basic angle alpha. So I have a right angle triangle. Based on the alpha, the opposite is 1. The hypo is 1 plus k square. So let's try and find out what is this other side over here. So this side would be, so 1 plus k square, square root and square, and minus 1 square. So this one, and then the whole thing need to square root. Okay, so this one would be just k, right? So this side is k. Alright, so when sine theta equals to cosine theta, so let us write down the expression for sine and cosine theta. So I have sine theta base is equals to sine alpha, right? Then this one, it will be negative cos alpha. Okay, just change to basic angle first. So sine this one, and then cosine theta is equals to negative cosine alpha. Okay, so what is sine theta? Sine theta is 1 opposite over that hypo, right? Hypo over there, 1 plus k square, right? Next one will be negative 1 over cos alpha, so it will be k adjacent over hypo. Okay, so then because the denominators are the same, I can remove them. So 1 equals to negative k, k would be equals to negative 1. So this is my answer for part A. Okay, now for part B, I'm going to make use of the same triangle, right? Same triangle. When secant of this is equals to negative root 5 over 2, so it means that the cosine of theta is equals to negative root 5 over 2. Now, what is cosine theta? Borrow the basic angle would be negative cos alpha. So this would be negative 5 over 2, root 5 over 2. Okay, so let's make it positive. So cosine alpha is equals to root 5 over 2. Okay, then what is cosine alpha? Because I'm looking for value of k. So what is cosine alpha? Adjacent over hypo. So adjacent over hypo would look like this. Right? Okay, so because I have square roots on both sides, why not I square both sides? So I square the left, right? Then I can square the right also. So I can square the right to look something like this. Okay, then let us cross multiply. So 4k square is equals to 5 plus 5k square. Oh, sorry, I made a mistake. Okay, let me erase everything on this side. Okay, you see so secant is this, right? So cosine would be reverse, right? Inverse, the reciprocal of this. Okay, now then this would be like this would be like that. Okay, this would be like that. Okay, remove the negative, then square 4 over 5. Okay, so 5k square, 4 plus 4k square, so k square is equals to 4. K, your square root will be plus 2 or minus 2. But let's check our answer and see which one is possible, which one it is. Okay, whether is it positive or negative. So when k is negative 2, okay, let's check the cosine theta. Sorry, let's check cosine alpha. Is it cosine alpha? Okay, let's check with this line over here. Okay, so if k is negative 2, okay, so you check so this one would be negative 2 over 1 plus negative 2 square. So this would be negative 2 over root 5, which is not equals to negative, which is not equals to 2 over root 5. Not equals to the right hand side. Okay, so you check left hand side and right hand side. So the left hand side in this case does not equals the right hand side. So this one we have to reject or inadmissible. Okay, so I put here NA. Okay, cannot. So the final answer is just k equals to positive 2. Okay, if you throw in, you will be satisfied. So actually the answer is positive 2. Okay, so that's all for the video on reciprocal trigo ratios. Okay, so I'll see you in the next video for some other concepts. Okay, bye bye.